And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world industries is generated by $3 billion worth of salary. That $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI.
Generative AI has triggered an explosion in software development, delivering massive speed upgrades to developers writing raw code. Developers are generating thousands of code commits, multiplying at a rate we haven't seen in the history of computer science. We have seen this exact pattern before. A new technology accelerates individual microtasks, but the macro productivity statistics barely move. Back in 1987, economist Robert Solow pointed out that the computing revolution was visible everywhere except in the productivity statistics. Assuming that a developer typing faster automatically translates to a company shipping more software is a fatal analytical error. We can see the break in the chain by examining recent telemetry data from over 100,000 GitHub developers actively using AI tools. When developers deploy synchronous AI coding agents, their raw code output surges. This chart compares that initial input to the final shipped output. Lines of written code jump by 741%. Actual software releases rise by only 20%. That gap exists because software is not built on a flat assembly line. It requires a hierarchical production model, which means human bottlenecks at any stage actively choke off productivity. To understand why a massive input yields a minimal output, we have to map the data against an economic framework known as the vertical weak link hypothesis. Between 2022 and 2025, AI tools evolved in 3 leaps, starting with basic autocomplete mechanisms, advancing to synchronous partners, and arriving at fully autonomous agents. This chart tracks the resulting task-level gains. Autocomplete tools provided a 40% gain in code commits. Synchronous agents pushed that to 140%. Asynchronous agents drove it to a 180% increase. The tools shifted from augmentation, helping a human type faster, to automation, where an agent writes and commits code autonomously. Regardless of how the code is generated, it all flows into the exact same review pipeline. Achieving task-level automation is a necessary step, but it is completely insufficient for overall pipeline efficiency. Modern software production requires a strict sequential aggregation of tasks. Code moves upward from lines to files, into commits, pull requests, projects, and final releases. Individual lines are organized into files, bundled into commits, integrated via pull requests, and packaged as a shipped product. Each of these upward transitions requires dedicated human review, team coordination, and architectural decision-making. Software is aggregated, not just written. That makes the product highly vulnerable to intermediate choke points. We can track the survival rate of an AI productivity shock as it moves upward through these layers. This graph maps the initial 741% surge in lines of code generated by synchronous agents. As it moves upward, the gain bleeds down to just 65% at the pull request layer, finishing at a 20% gain in final releases. This geometric decay is not caused by bloated AI code or errors in data measurement. It points to a structural constraint in the system. Exponential volumes of AI-generated code are piling up behind a fixed human review bottleneck. Economists map this kind of decay using the constant elasticity of substitution model. At each layer, production relies on effective input, a specific combination of upstream AI-generated code and downstream human review effort. The variable controlling the survival of the productivity shock is sigma, which measures the elasticity of substitution. This formula governs the bottleneck. Sigma dictates whether a surplus of upstream input can actually substitute for a lack of downstream human effort. If sigma is greater than 1, AI and humans are substitutes. AI code could simply replace human reviewers, allowing the massive productivity gains to pass all the way to final release. Calibrating this model with telemetry from 100,000 developers reveals a sigma of exactly 0.25. Mathematically, a sigma of 0.25 forces the exact geometric decay we see in the hierarchy. A sigma under 1 proves strong complementarity. Raw AI output is useless without a proportional application of human review. If human review remains the bottleneck, generating infinite amounts of upstream code will yield strictly bounded final output. This constraint extends past the developer pipeline and directly into the macroeconomic reality of major app marketplaces. A 20% increase in release software only matters if it generates equivalent value for end consumers. Starting in early 2025, the agentic coding era triggered a sharp expansion in the supply of new applications hitting the market. This chart compares supply against consumer engagement. On the left, App Store release counts climb. On the right, user downloads and ratings remain completely flat. This divergence occurs because the growth in software releases is concentrated entirely in applications that acquire 0 users. The supply-side expansion merely hit a new bottleneck on the demand side, the limited bandwidth consumers have to discover and adopt new applications. Breaking a production bottleneck yields no economic advantage if the downstream distribution pipeline is sealed. The bottleneck is simply traveling sequentially through the software economy. Basic autocomplete solved the friction at layer 1, writing code. That immediately transferred the pressure to layer 4, the human review of pull requests. Autonomous agents will eventually clear that review layer, only to push the friction entirely onto the consumer's ability to curate and download software. When you force massive volume through a tightly constrained system, the pressure simply transfers to the next narrowest pipe. The vertical weak link hypothesis acts as the governor of technological disruption across any industry built on sequential tasks. For now, task-level AI guarantees localized speed, but true aggregate economic growth requires the systemic automation of the entire hierarchy.